Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is a pretty classic question from an area of calculus called implicit differentiation. So we're going to use implicit differentiation to solve this. We have a 6-foot ladder leaning against the wall, and the ladder is falling. Notice that as the ladder falls, y will become smaller and x will become larger. X is the distance between the bottom of the ladder and the wall, as you can see in the diagram. At the point in time that we're interested in, the angle from this angle of elevation for the ladder is 25 degrees. So you can see up here I started with just finding expressions for x and y using SOHCAHTOA from our right triangle here. And now we just use Pythagorean theorem to set up an equation, and we're going to take the derivative with respect to time. And that's going to be 2x dx dt, 2y dy dt, and the derivative of a constant is always 0. And now we're just substituting in here. X we found up here is 6 cosine of 25, but it's being multiplied by 2, so it's 12 cosine 25. And we're told in the problem that dx dt is, in other words, x is becoming larger as the ladder falls, and it's becoming larger at the rate of 0.5 feet per second. So I have a half here. And then 2y, so 2 times y is 6 sine 25, so that's 12 sine 25 times dy dt is 0. And that's what we want to know. So now we just isolate dy dt. So we're going to bring over this term here, bring it over to the right-hand side, so it becomes a negative 6 cosine 25. And we're going to divide by 12 sine 25. And when we do that, we get negative 1.07 feet per second. So what's happening is this height of the ladder, the height of the wall that the ladder is covering, that height is dropping at roughly 1 foot per second, whereas the length, the distance of the bottom of the ladder, which would be, let's say, here after a drop, that length is getting bigger at the rate of 1/2 of a foot per second. So this distance is getting bigger at a smaller rate than the distance of the ladder, the height of the ladder against the wall, the height of the wall at the top of the ladder. Sorry, the word's getting a little jumbled up there, but I think you get the idea. So this is changing slower, and then this is changing faster. So that's a very useful thing to know, especially if you want to get out of the way of that ladder. So I hope this helps you, and I'll see you again next time. Bye-bye.